Lesson 87, more on systems of equations and test for functions. The new tests for functions are the tests for functions that you may or may not remember. A graph on the coordinate plane represents the graph of a function provided that any vertical line intersects the graph in at most one point. Okay, more on systems of equations. A part, we're given r sub 1 t sub 1 equals r sub 2 t sub 2. We're told that t sub 1 plus t sub 2 is equal to 60, and r sub 1 is equal to 3, so we can start substituting in. R sub 2 is equal to 6. Now, we're also given this equation, t sub 1 plus t sub 2 equals 60. If we rewrite that equation by subtracting t sub 2 from both sides, we get t sub 1 is equal to 60 minus t sub 2. Now, we can substitute that 60 minus t sub 2 in the place of t sub 1, right there. So we've got 3 times 60 minus t sub 2 equals 6 times t sub 2. To clean up, we get 180 minus 3 t sub 2 equals 6 t sub 2, and then add 3 t sub 2's to both sides. Now, do not let those subscripts affect your work. Those are just a variable. And then divide both sides by 9, and t sub 2 turns out to be 20. If t sub 2 is 20, then t sub 1 is equal to 60 minus t sub 2, so t sub 1 is equal to 40. B, again, looking at equations and evaluating equations. These are r sub 0 and t sub 0. Okay, I'm going to write it over to the side. R sub 0, t sub 0 equals r sub s, t sub s, plus 16. R sub 0 plus s plus r sub s is equal to a negative 1. Now again, if we're solving for the r sub 0 or the r sub s, it doesn't matter. I'm going to subtract r sub s from both sides. And I get r sub 0 is equal to a negative 1 minus r sub s. Now, let's see what I can substitute in. I know t sub 0 is equal to 8. I know t sub s is equal to 4. And I know r sub 0 is equal to a negative 1 minus r sub s. And we already have the r sub s plus 16. So when we do the distributive property with that 8, it doesn't matter whether the 8's in front or behind, we get a negative 8 minus 8 r sub s equals 4 r sub s plus 16. By adding 8 r sub s to both sides, we get a negative 8 is equal to 12 r sub s plus 16, and then subtracting 16 from both sides, we get a negative 24 is equal to 12 r sub s. Dividing by 12, we get r sub s is equal to a negative 2. Now, to find r sub o, we go back and substitute in. R sub o is equal to a negative 1 minus r sub s, which is a negative 2. So we get r sub o is equal to a negative 1 plus 2, or r sub o is equal to 1. Determine whether each graph represents the graph of a function. And we're looking at this vertical line test. C, yes, it is. It is a vertical, it does follow it is a function because it passes the vertical line test. There's no way to draw a vertical line that would cross that more than once. So C is a function. But when you look at D, when you draw a vertical line, it's crossing that graph at 2 places. So no, it is not a function. And E, again, the vertical line test, it will not cross it but 1 time, so it is a function. That's your vertical line test. Lesson 88 is quadratic equations, solution of quadratic equations by factoring. The zero factor theorem says if P and Q are any real numbers and if P times Q is equal to 0, then either P is equal to 0 or Q is equal to 0, or both P and Q equals 0. Solve by factoring. All right, now remember, when you've got a quadratic equation, everything must be moved to one side. So we're going to add 5x to both sides. We're going to subtract 24 from both sides. And then all that will be left over there is 0. Then we want to factor it. Again, that method of factoring that I taught you, a negative 24x squared, multiply the constant times the quadratic term, and look for factors that will have a difference of 5. So, 8x and a negative 3x. So if we write this x squared minus 3x plus 8x minus 24 is equal to 0. Then factor. And so we have x minus 3 when we factor that out, and what's left is x plus 8. Now, we're solving this by factoring, so it says either P is equal to 0 or Q is equal to 0 or both of them. So x minus 3 equals 0, x is equal to 3. X plus 8 equals 0, x is equal to a negative 8. So there's your 2 solutions. B, again, solving a quadratic equation. We've got to have the 8x has got to be added to both sides. So now put them in order. X squared plus 8x minus 48 is equal to 0. When you multiply these two together, we get a negative 48x squared, and we want 2 values multiplied together that will give me a negative 48x squared, but when I add them, I get a positive 8x. So a positive 12x and a negative 4x. So x squared in the place of that 8x, I'm putting those values. Minus 4x plus 12x minus 48 is equal to 0. And then I group and I factor. X times x minus 4 plus 12 times x minus 4 is equal to 0. Factor out the x minus 4, and you have x plus 12. And then set both parts, when you're solving by factoring, set both parts equal to 0. By subtracting 12, by adding 4. And then lesson 89 is value problems, which are very much like coin problems. Tickets for good seats cost $8, and tickets for the other seats cost $3. If 18 tickets were sold for the total of $119, how many tickets for good seats were sold? Let G equal the number of good seats. And put your value out at the end of a good seat. Let B, we're going to call them bad seats because we don't want to use O because it looks like a 0. So B be the number of other seats. And their cost was $3. There were 18 tickets sold, so G plus B has got to be equal to 18. And then they made $119 off their sales, so 8 times G plus 3 times B is equal to 119. Now, I would suggest go ahead and use the elimination process. Multiply the top one maybe by -3. We get a -3G minus 3B is equal to a -54. 8G plus 3B equals 119. Those will cancel. 5G is equal to 65. And divide by 5. And the number of good seats was 13. And how many tickets for good seats were sold? There were 13 tickets for good seats sold. B, at a basketball game, adult tickets sold for $5 and children's tickets sold for $2. If 175 tickets were sold for a total of $686, how many of each type were sold? Again, let A equal the number of adult tickets. It's very important that you do your labeling. And the adult tickets sold for $5. And C equal the number of children's tickets. And they sold for $2. There were 175 tickets sold. A plus C equals 175. And that for a total of $686, so you have to put the money with it. 5A plus 2C equals 686. Multiply that top equation by -2, and we get a -2A minus 2C equals a -350. And 5A plus 2C equals 686. And we get 3A equals 336, and divide by 3. So the number of adult tickets was 112, and then the adult tickets plus the children's tickets were equal to 175. The adult tickets was 112, plus the number of children's tickets was 175. So the number of children's tickets was 63.